All right, we're going to talk about rational functions, but I want to first point out the difference between reciprocal functions and rational functions. So reciprocal function, we know the reciprocal is basically when you take a number and flip it. So we've got we talked about this, about f of x equals x or y equals x. The reciprocal of this is basically we're just taking that x and putting 1 over it. That's what we're talking about with the reciprocal function. Also notice that whenever you have a reciprocal function here, there is only a number in the numerator. That's it. There's just a constant or a number in the numerator. A constant or a number in the numerator. So now when we talk about rational functions, we're going to be talking about basically where we have an x in the denominator but there's also an x in the numerator. I should have put that in the opposite order, but basically an x in both the numerator and the denominator. And so our form basically looks like f of x equals p of x divided by q of x. All right, so this is different because of the fact that we have both an x in the numerator and in the denominator. So now let's talk about our x-intercepts. And this is basically when we have the graph crosses the x-axis. So this is where the graph is going to cross the x-axis, graph crosses the x-axis. And when that happens, it's when our y equals 0. So the way you determine this is you set your numerator equal to 0. And that will give you your x-intercepts. Your vertical asymptotes are going to be basically the same as we've been doing before. You're going to set your denominator equal to 0. And that will give you your vertical asymptotes. This is going to be a vertical line. It's a boundary. This is a boundary. A boundary line. And you must put x equals. Do not forget that. All right. Now, this is where it starts getting fun, the horizontal asymptotes. So, when we're talking about the degrees, we're talking about the exponents. And if you have your exponents, you're looking at your very largest exponents. And if the degree of the exponents of your numerator, top, is bigger than the degree of your exponents on the bottom or your denominator. If the top is bigger than the bottom, we're going to have no vertical or no horizontal asymptotes. And the way that we can kind of remember that is bigger on top, none. Bottom. Bigger on top, none. If the bottom is, if the top, keep wanting to do that. If the top is smaller than the bottom, then you're going to have an asymptote of 0. So y is going to equal to 0. And the way that we're going to remember that is BOBO. Bigger on bottom is 0. Bigger on bottom is 0. Bigger on top is none. Okay? So BOBO, bottom. I know that sounds weird, but we're going to make a fun story about that someday. Then if the degree of P equals the degree of Q, then you basically are going to have where Y is going to equal the leading coefficient of the numerator divided by the leading coefficient of the denominator. And how are we going to remember that? Well, it's going to be eats DC, which stands for exponents are the same. Then you're going to divide coefficients. Okay? So when the exponents are the same, you're going to divide the coefficients. So is Bobo Botten going to eat DC? Well, hopefully our friends Hoy and Bucks are going to come save the day and help us out with that. All right. So that's how you figure those things out. Then we've got some holes that we need to discuss. And the holes are where you have a factor in the numerator as well as the denominator. Okay? So for an example, if I have x plus 2 divided by x plus 2, x minus 3, your hole is going to occur at the place where they would cancel each other out. So your hole is going to occur where these would simplify to 1. So you're going to take your x plus 2, set that equal to 0, x equals negative 2. So at the location of the hole, your x coordinate is going to be negative 2. Now remember that a hole is a coordinate point. So you've got an x and a y coordinate. This has now simplified to 1 over x minus 3. And so I need to figure out, based on this, where the y value is. So I'm going to take y equals 1 over x minus 3, and I'm going to plug this negative 2 in to that equation. So I'm going to have y equals 1 over negative 2 minus 3. So my y coordinate in this situation would be y equals 1 over negative 5, or basically y equals negative 1/5. So my coordinate point of that hole is going to be negative 2, negative 1/5. And we'll go over that more on our problems. Okay? So let's do a couple of these problems. Step 1 is going to always be to simplify. I'm going to use a different color. We're going to always simplify first. I'm going to have to factor. You always want to factor and simplify. So I can factor this. This is a perfect square binomial. There's two numbers. They're both perfect squares, which means I'm going to take the square root of x squared. I'm going to get x and the square root of 9, which is 3. That x plus 3, if I were to multiply those two factors together, I would get x squared minus 9. And on top is going to be x plus 2. So right away I'm noticing that there are no holes. So I'm going to go ahead and write none here, because right away I'm noticing that there are no holes. I don't have anywhere I can cancel out. My x-intercept is going to be where my numerator. So this was step 1. Step 2 is for my x-intercepts, and I'm going to put my numerator equal to 0. But I actually have 2 factors of my numerator, so I actually have to do it twice. X minus 3 equal to 0, as well as x plus 3 equal to 0. So that's telling me I'm going to have 2 x-intercepts. X at 3 and x at negative 3. So those points are going to be 3, 0, negative 3, 0. Because these are where my y would be 0. So I can graph those points. Negative 3, 0, positive 3, 0. I don't have to worry about any holes. I already determined that there were no holes. Number 3. What about my vertical asymptote? That's going to be where my denominator equals 0. So I'm going to take my x plus 2, set that equal to 0, and I'm going to see that it's x equals negative 2. So my asymptote is x equals negative 2. Please remember to put that x equals. That is very important. You will get counted off if you do not do that. So I'm going to put my asymptote here at 1, 2, and I'm just going to go ahead and draw my vertical line at x equals negative 2. Then I can go ahead and determine that my domain, I'm going to wait to, is going to be x cannot equal negative 2. And since I don't have any holes, I don't have to worry about another value. Now my horizontal asymptote, this is where we've got our Bobo Baden eats DC. Is it going to be Bobo? Is it going to be Baden? Or is it going to eat DC? So let's see. I'm going to look at here, and I see that x is squared. And here, x is to the first power. X is to the power of 1. So I'm bigger on the top. This x squared is bigger than the x. So if I have a bigger on top, that's going to be my Botten, my Bobo Botten. So bigger on top, what kind of a horizontal asymptote am I going to have? None. I don't have one. So my range is not limited at all. I'm going to have a full range. So, oops, I didn't mean to write that. So my range is basically going to be all real numbers. So let's see what that looks like on a graph. Now, if I did not have a graphing calculator, I could just start plugging values in x and y and determine just from here if x were to be what number, how that would work. If you don't have a graphing calculator, then you might want to do that. So we're going to plug in, I'm going to make sure that my numerator is 100% completely in parentheses. My denominator is in parentheses. So I'm going to get x squared minus 9. Oh, here I just said I was going to put in parentheses and I didn't. Parentheses x squared minus 9 into parentheses divided by parentheses x plus 2 into parentheses. If I don't put them in parentheses, it's not going to work. And that is an interesting graph. So let's look at this and look at our table. And I've got negative 3, 0, good. I've got 1, negative 8, so I'm going to do negative 1, negative 8. That's going to be down here. And I've got 3, 0, which that's good. So if I were to go ahead and graph that, that would look like that. What about on the negative side? I've got negative 3, 0. What would be a, I don't see any whole numbers. So let me just pick one. Oh, here's negative 7, negative 8. So negative 7, negative 8. And it'll look like that. And that looks pretty close to what my graph there looks. Okay? And if you wanted to, you could go ahead and write your 3, 0, negative 1, negative 8. This would be negative 3, 0, and negative 7, negative 8. Okay. Now, what about this next one? I have a feeling there might be a hole here. So let's see. We've got what numbers are going to multiply to give me negative 5 and add to give me negative 4. It's going to be negative 5x plus 1. If I were to multiply those together, I'd get negative 5. If I were to add them together, I'd get negative 4. So that's perfect. This I can factor into x minus 1. This is also a difference of two squares, x minus 1, x plus 1. And lo and behold, I can cancel these out. So my new simplified equation is x minus 5 over x plus 1. I think we've already done this, but let's keep going. So, number 1, step 1, I've factored and simplified. Step 2, I'm going to find my x-intercepts, which means I'm going to set my numerator equal to 0. My numerator is x minus 5. This would be my y-coordinate. What is x when y is 0? Well, x would be 5. So I've got a coordinate point of 5, 0. So I can plot that. 5, 1, 2, 3, 4, 5, 0, right there. Then I'm going to look at my vertical asymptote when I set my denominator equal to 0, and I'm setting the simplified denominator. So x minus 1 equals to 0. Basically what this is saying is this cannot be 0. The denominator cannot be 0. So we need to figure out what line is it that cannot be touched. What is my boundary line? And that is x equals 1. So I can go ahead and graph that at x equals 1. It's going to be a vertical line at x equals 1. Then I'm going to look at my horizontal asymptote, which is, I've got a 2 is my largest degree on the numerator. 2 is my largest degree on my denominator. So if I'm thinking Bobo Baden eats DC, is it bigger on bottom? No. Is it bigger on top? No. Are the exponents the same? Yes. We got a 2 and a 2. The exponents are the same. So when their exponents are the same, they're going to eat DC, right? Exponents are the same. We're going to divide the coefficients. The coefficient of this exponent is 1. So y is going to equal the coefficient of that divided by the coefficient of the denominator, the leading exponent of the denominator, which is 1. So my horizontal asymptote is going to be y equals 1. And I can graph that. So I've got y equals 1 and x equals 1. And now we've got this beautiful hole that I need to deal with. So we've got a hole, and I'm going to get a piece of paper, another piece of paper. Because I can't fill in my domain and my range yet because I don't know where my hole is. So we've got to figure out where the hole on the graph is going to be. So I know that it's at x plus 1 over x plus 1. So I'm going to take x plus 1, equal that to 0, and get x equals negative 1. So when x equals negative 1, that's going to be my x-coordinate. What is my y-coordinate going to be? So we're flipping back and forth, and this is something that hopefully you guys are starting to see, is that there are times we're talking about ordered pairs where they're an actual point, and there are times where we're talking about lines, because it does look very similar. This is a line. This is going to be a point. Now we're talking about a point again. This is a point. This is a line. So please make sure you're kind of understanding when it's a point versus when it's a line. So if I have x equals -1 as a point, I need to find out the y coordinate. So I'm going to take my x minus 5 divided by x minus 1. That's my y equals. Taking this equation, and I'm going to plug in x minus 1 for my x value. So I get -1 minus 5 divided by -1 minus 1. Taken this and plugged it in for my x value. And I'm going to get -6 divided by -2, which that equals, of course, 3. So I get -1, 3 is my whole. So I'm going to go -1, 1, 2, 3, and mark that as a whole. So now when I'm looking at my domain, I have to take into consideration the asymptote as well as the whole. So x can never be -1 or +1. And y can be any number except 1 and 3. So now when I'm looking at on the graph, I was going to graph that. You can plug this in and it'll actually help you see the holes, or you can just plug this in. It's a good way to check it if you plug that in. Let's go ahead and plug this one in. So if I did x squared, oops, that's not x squared at all, x squared, darn it, parentheses, x squared minus 4x minus 5 divided by parentheses x squared minus 1, and graph that. That's good. Now let's look at our table, and we should have an error at -1, which we do because that shows where our hole is. And we should also have an error at +1, which we do. That shows our asymptote. So we're in good shape. So if I was going to plot a few more of these points, I've already plotted 0, 5. I've already plotted, or here we can plot 2, -3, 1, 2, -1, 2, 3. So that's going to give me a little bit of the shape of that one. And then when I start going -3, 2, and I know it kind of should go through that hole, so that'll kind of give me the shape of that graph. So hopefully that helps you guys. Just keep in mind that when you're doing rational functions, when you have a rational function with the x in the numerator and in the denominator, your horizontal asymptote, you're going to be doing your Bobo, Bodin, eats DC. Everything else is pretty much the same. All right. Have a good one.